The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents. Amazing hacks, inspired designs. Each week, Element 14 Presents brings you innovative projects using electronics, engineering, and more.
Greetings, programs, and welcome back to Element 14 Presents. Matthew here, you there, coming to you live and direct from the quarantine backup laboratory location, complete with quarantine hair. Yeah, it's been a little while. As you can see, I don't have a heck of a lot of room to work here. And of course, I don't have my full complement of resources like I do over at the shop. That being said, I'm gonna have to put some of my bigger projects on hold for a little while and focus more on smaller things that I can work up right here on my little rickety table setup. That brings me to this project. Now, you have seen me build the Altair laptop. You have seen the Commodore SX64 Extreme Restoration. I've been wanting to do another retro computer project, but I wanted to do something with a Z80 processor in it, as I never really had a chance to work with one back when they were actually a thing. So that brings us to this project. This is the RC2014 Full Monty Kit. It is a Z80 homebrew computer that's sort of loosely based on like the ZX series or maybe the Apple I. It's got a lot of different sort of design influences, but it's a wholly different project. It's kind of neat because it is a modular design. It has a clock module and it has a ROM module and a RAM module. Everything's on little daughter boards, so it makes it really easy to kind of see what's going on and to kind of mess around and tweak a few things here and there. So I've been wanting to put this together for a while. I just haven't had a good chance to do it until now. So that's what we're going to do in this episode. We are building the RC2014 kit. It is a super solder episode, so go ahead, turn your fans on, tin your tips, and let's get started. The RC2014 is broken out into several different daughter boards, each one serving a specific function of the computer: CPU, RAM, ROM, etc. We're going to start with the CPU board, which just holds the Z80 and breaks out its pins into a 40-pin header that plugs into the backplane that we'll see later. This is the simplest board in the kit, as the only other part is this 3300 ohm pull-up resistor on the interrupt pin. I'm actually going to make this board slightly more complex though, as I'm going to install some header pins on wait, NMI, and bus request, just in case I want to break those signals out later. They need to be tied to 5 volts, so I'll throw some jumpers on there to take care of that. probably used too much flux on this board, so I'll just have to clean that up a little bit. And there we have it. This is one of the older RC2014 kits, so it has the switchable 8K ROM package instead of the pageable one, which is fine to play around with. It's just a 27C512 EEPROM and a 74LS32 OR gate package, but the wiring is kind of interesting, as there's this set of jumpers over here that will select which 8K of the 64K chip that the computer reads. I suppose in theory I could burn up to 8 different ROM images onto this thing and at least be able to switch between basic and CPM, assuming I have enough RAM, but I might be getting ahead of myself here. Those jumpers are connected to A13, A14, and A15 on the ROM chip, since we're not using those lines from the Z80. Now, speaking of those address lines, a couple of things to note. The Z80 itself needs A13, 14, and 15 to all be low in order to trigger the chip enable on the ROM. At the same time, read and memory request have to be low to trigger output enable. This is all managed by a little bit of clever wiring in the OR gate chip, cycling CE and OE as it needs. Good, now that's ready to go. The RAM board is set up very similarly to the ROM board in that it uses another 74LS32 OR gate to control its actions. Write enable and output enable on the 62256 32K RAM package are controlled through the OR gate output based on the state of the mem request, read, and write pins on the Z80. The interesting thing here is the use of a 74LS04 NOT gate on A15 to control chip enable on the RAM. Essentially, it's a simplified version of the OR gate complex from the ROM board, and it's only using one gate on the package. So I feel like it could have been a lot simpler and probably more fun just to use a transistor here, but that's just me. I got a soft spot for discrete components. Looking pretty good. Now the clock module's kinda cute. It's this teeny tiny little board compared to the others. Lots of discrete components, a couple of parallel RC circuits with a 7 MHz crystal between them. There's even a little spot for a little tack switch if you want to use it for the reset line. I'm gonna save mine for the backplane, but I guess I could solder one in later. Then you've got this 74HTC04 inverter package to create the oscillating signal going to the Z80. Aesthetically, this might be my favorite board. Look at it, it's just so compact and cute.
Hi, I'm David from Element 14 to the Electronics Inside. Join me as I tear down toys, tools, appliances, modern, vintage, classics, and even some new releases just to find out what's inside.
The serial I/O board could be the most complicated board in the mix, but I'm going to opt for the easy assembly that just uses the FTDI header instead of the RS232 serial connection. I mean, if I built another single board terminal like I did for the Altair 8800 laptop, I could use that, but that's way too much to try to fit on my little table right now. I just want something to play around with during these unprecedented times. But I'll probably add that in later, you know, just for the lulz. Anyway, the RC2014 uses an MC68B50 ASIA to do all the communication. So all I have to do is plug in an FTDI USB to UART dongle and I'll be off to the races. I do need to make sure to add this little jumper header so I can power the whole thing from the FTDI cable too. Sure beats having to find a compatible wall wart. Alright, looks like all the hard stuff is finished. Now, this backplane is super simple. It's just a bunch of headers and filtering capacitors for each board. There's a lot of room for expansion on this thing, so I'll probably revisit it sometime. Be sure to check out my blog on the element14.com for those updates. For now though, I'm just going to finish out the bill of materials with the power jack, the power LED, and the reset switch. Now let's get this thing assembled. Chip it up, plug the boards in, and give it a test. Okay, so looking pretty good so far. Time to test this thing and make sure it works. I have my FTDI cable, the little serial cable plugged into the lappy here. Now we got a power light, that's a good sign. All right, and let's start up the screen. Okay. Yes! All right. Yeah, looks like it works. Let's see, let's try something really simple. Sweet, it works, fantastic. Okay, so one last thing I want to do is I want to put a little case together, you know, just so it's not like a bare board there. Something simple, just going to throw it together on the 3D printer and we shall be good to go. Okay, so looking pretty good in its new case. Let's put some programs on this thing and see what it does. I guess the best place to start would be my archive of 321 contact magazines. What, like you don't have an archive of 321 contact magazines with basic programs in them? Come on. Let's try this one. This one looks interesting. Whee! Okay, here is an interesting one. This is basically like a poetry generator that kind of just like remixes lines from Edgar Allan Poe's The Raven. It's complete gibberish, but it's kind of interesting. It just kind of randomizes the different like little phrases and just sort of builds a poem out of it. It's kind of what I love about BASIC, is that it's just like basic. So a lot of stuff that you find as far as like programs that people wrote, they're all just very simple and just sort of weird, sort of artsy kind of remixing things that already existed. And there's a lot of like math programs, you know, that people used a lot, but I love stuff like this, and I love little like games where it's like, you know, guess the thing. My favorite is the text adventure, and I wrote a lot of text adventures as a kid writing basic programs. That's really where I cut my teeth, was writing text adventure games a la Zork. Okay, now speaking of little guess the number games, so I was thinking of a whole number between 1 to 100, and then what it'll do is it'll give you an amount of stars to kind of show how close you are, like warm, cold kind of thing. Do this algorithmically. We start at 50, and that's a 4 out of 7. So let's go down to 40. That's closer. 30 is not as close. That means 35, 37. There it is. It's like you just divide it in half every time and you'll find it. 50 is not that close. Okay, so let's go 60, 70. All right, 70 is closer. 80 is closer. 90 is closer. 99. There it is. 50 is not close. 10 is also not close. 90 is very close. 95, not as close, so it's 85, 87, 88. Oh, the 91, I was the wrong direction. You get 7 guesses, apparently, so it's a fun little game. Okay, so here it is, the newest member of my retro computer collection, the RC2014. And what I love about this one in particular, besides the fact that it's just rock basic simple and easy to understand, it really does a fantastic job of illustrating how a computer works. Everything is connected along bus lines, and you have all the basic components. You have your clock, your CPU, your ROM, and your RAM, and you can see, well, you can't really see, but you can understand with the wiring back and forth how it's actually going about its business. And that's what I really love about retro computing in general. It's not really so much a nostalgia for a time bygone, although that's part of it, yes, but there's also this celebration of the sheer ingenuity of humankind, and engineers and technicians and scientists coming together, being able to essentially trick rocks into thinking. Most of that is really just hidden behind layers and layers of abstraction, and nobody really kind of understands that anymore. And I feel like that's where this retro computing aesthetic, or this wave, or this hobby, or whatever you want to call it, that's where it really shines, is the educational aspect of it. I'd also like to add a little bit of expansion here. We got plenty of expansion slots, and there's so many different modules available for this thing. I'd love to play around with those, maybe even design my own at some point, and just kind of have fun with it, because that's really what it's all about here, especially when you have limited resources and there's things going on outside. You can't really leave the house very well. Having as much fun at home as possible is a lifesaver, quite literally. In the meantime, you tell me on the Element 14 community at element14.com/presents, what is it that you enjoy the most out of the retro computing scene? While you're there, you can check out contests and news and product releases, and so much more, including my continued adventures with this little board. So check that out as well. In the meantime, my name is Matthew, and until next time, remember, it's okay. It's just a prototype. Tally ho, y'all.